Here is your momentum exam review. I've got the exam right next to me. I'm going to be looking it over as I review what you need to know. So, this unit has two main ideas. Well, actually, let's just define what momentum is. And then we need to talk about the impulse. Impulse momentum theorem. And then we'll talk about conservation of momentum. So here's a definition of momentum. First of all, momentum, which we use the lowercase p with a vector hat on it to represent, is just an object's mass times its velocity. That's it. It's pretty easy. And that has units of kilogram times meters per second. And the main thing to remember is that momentum is a vector. So if something is moving in this direction, okay, its momentum vector, this would probably be, we would make that negative, right? So because to the left is negative and to the right would be positive. So if something has momentum like this, that's different than having momentum like this. Direction matters. Okay, now we derived our definition of this from the impulse momentum theorem. Remember we said that the net force equals mass times acceleration, right? Newton's second law. Well, from that, we said that this is mass times the change in velocity over the change in time. And then we just took change in time and put it over there. And so we have the net force times our change in time will be equal to our mass times our change in velocity. Well, what is mass times velocity? That's momentum. So really this is a change in momentum. And this is the impulse momentum theorem, that if I apply a net force times time, that will equal the change in momentum of an object. So this is a product, force times time equals a change in something. P final minus P initial. Okay, this is force times time is impulse. Give it units of newtons times seconds. That's a change in momentum. That has units of kilogram meters per second. But if you reduce a newton second, it reduces down to a kilogram meter per second. So they are equivalent to each other. And there will be impulse problems on the exam. If I give you a force times time, you might have to figure out the final velocity, if I know the initial velocity or whatever, but you would set it up this as your basic equation on some of the problems that I give you. Also, whenever you have a product like this, let's say force depends on time. How would you multiply them together? Well, you would just draw a graph. Here's a force times time, and let's say I have something like this. Like, what's the change in momentum here? Well, if this is force and this is time, the area underneath the graph represents our change in momentum. This is always true. If I have a quantity that is the product of two other quantities, then I can figure out what that third quantity is by graphing forces. The first quantity is a function of the second quantity. The area underneath the graph is the third quantity. There will be a problem where there's a graph like this on the test, and you'll have to figure out what the area underneath it is. Break it up into rectangles and triangles and add them together. And you will have the area, which is the change in momentum, which is also equal to the impulse. You can use the letter I for impulse if you want to. So there'll be a bunch of problems and questions about the impulse momentum theorem. Now, then we're going to deal with explosions and collisions and explosions. And during collisions and explosions, we say that we have conservation of momentum. Let's suppose two objects are moving at each other. This object's moving like this. Maybe this bigger object is moving towards it, and wham, they're going to collide. Well, when they hit, they apply equal and opposite forces. That's Newton's third law for an equal period of time. So during the collision, here's the force that they apply to each other. Okay, equal and opposite forces. Now, by the way, these arrows up here are the momentum arrows, but this is a force arrow here. Object 1, object 2, object 1, object 2, force on 1, force on 2. But these forces, which are equal and opposite, that's Newton's third law, apply for the same period of time. And that means, with the impulse momentum theorem, that the change in momentum of object 1 will be equal, but in the opposite direction as the change in momentum of object 2. Well, this is P final minus P initial for object 1, and this is minus P final minus P initial for object 2. And then what we do is we put this negative in here, which makes this a negative and this a positive. And then I'm going to put the initial momentum over here and add this final momentum over here, and we get P final 1 plus P final 2 is equal to P initial 1 plus P initial 2. Now this is all the momentum in our system. This is our closed, isolated system. And so this is the final momentum of my system equals the initial momentum of my system. So in other words, during the collision, yeah, this object 1, had its momentum changed. And this object had its momentum changed. But those changes are equal and opposite, so there's really no net change in momentum for your system. That's conservation of momentum. And you will have a collision problem, or a couple of collision problems, where this is where you start. And it doesn't matter. You can start off with initial momentum equals final momentum. Just switch the order of this, doesn't matter. And you can use that to solve problems. And these are all the main ideas that will be on the test. Okay. And now what I'm going to do is read through the test. Now, the first 10 things on the test are 10 multiple choice questions. And let's see. They deal with, I'm holding it in my hand right now. Can you define what linear momentum is? Yeah, mass times velocity. And do you know what impulse is? Yes, force times time. Do you know the impulse momentum theorem? That the impulse is equal to the change in momentum of the object. Okay, that's on there. What do we mean by an isolated system? Okay, that means no net outside force acting on your system. Make sure you understand what an internal force is. An internal force, here's an internal force. If this is my system, when these two collide, they each apply equal and opposite forces to each other. So as a system, there's no net force there. Because these forces are internal to my system. Now, if I define object 1 to be my system, then, this is not internal anymore. The force that object 2 applies to object 1 is now considered an external force because it's coming from outside our system. But if I make the two objects my system, if I say, no, object 1 and object 2 are my system, then these two forces are internal to that system. They don't change the momentum of my system. And then I've got a couple little problems. An explosion problem. An explosion problem is just like a collision problem, except the two things push each other apart afterwards. And let's see, we've got a couple things here. Make sure you study the take-home test problems thoroughly. There's a couple of multiple choice questions, particularly the one where you catch the ball with your hand. Make sure you study that take-home test problem. Oh, and then there's one where I think they want to know what has the biggest change in momentum, where the bullet embeds itself in the block or where the bullet bounces off the block. Okay, there's a multiple choice question about that, so make sure you study that. Okay, then I'm turning the test over. There are two short essay questions. They're worth 5 points each. The multiple choice is worth 1 point each. Now make sure that you can explain, like I did here, why momentum is conserved when two objects collide. Use Newton's third law, equal and opposite force. Use the impulse momentum theorem, because that force is applied for equal times. So you have equal and opposite impulses, and that leads to conservation of momentum. You're going to have to explain that on the test. Make sure that you know that momentum is mass times velocity, and that velocity is a vector, and that momentum is a vector. That's kind of number 12 kind of deals with that. Now 13, 14, 15, and 16 are problems. They're worth 10 points each. The short answer things are worth 5 points each. But the problems, okay, number 13 is basically an impulse problem. A force is applied, net force is applied for a period of time, change in momentum. You're going to have to use the impulse momentum theorem. Number 14 is a collision problem where two objects come together and stick together afterwards. Okay, so if you have a collision problem, you start with P initial equals P final. Remember, if they're stuck together, if two objects come together and stick together after the collision, then you just add the masses, right? And they have, because they're stuck together, they have a common final velocity. So I think we've worked several problems like that. Number 15 is about a bullet being shot into a block, so I think Owen will like this problem. And it does involve this one. Oh yeah, this one. This one's a little tricky. Make sure you review. Well, I'll just give you a hint on it. Get a piece of paper. This is number 15. I suppose I have a block, and let's see. You shoot with a bullet. Here's a bullet, and it's moving really, really fast, and it embeds itself in the block. So this is going to be moving with a high velocity. This is going to be at rest. You shoot it. The bullet transfers all its momentum to the bullet block system here, right? And I want to know, how fast that's going. Okay, I just kind of told you the problem, but I give you a coefficient of friction. How far is this going to slide before it comes to a stop? Ooh, how are you going to do that? I don't know. We'll find out. And then number 16, I'll just give you a hint here. It's an impulse problem where I give you a force. Force is a function of time. You have to figure out the area underneath here is change in momentum. So you'll need to solve a problem figuring out the area underneath that graph. Make sure you know that that's change in momentum, and you should be able to solve the problem. Pretty easy. It's actually not a difficult problem if you know what you're doing. This problem, number 15, requires a little work. All right, I've given you lots of hints here about what's on the test. Study, 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 and hopefully you will prevail. Good luck. That is all.